Okay, so now we're going to find this side, right? The direct distance between the observer and the top of the tower, which is technically lowercase c, right? So how do we do that? We do have a pair, right? The same one we used up here already, sine 53. So for b, I would do sine of 53 over 325 is equal to, now we're going to use the 100 because that's across from c. Okay. And so c is 3 already.
Thank you for your attention, staff and students. As part of our school's Remembrance Service, we will be playing the national anthem ahead of this afternoon's showing of Stifler Remembers. Teachers and students, please rise for the singing of O Canada now and share our remembrance video immediately after.
We figured out that this is the direct distance from the observer and this is the length of the tower. But I would like to add another part to this. And so it's going to be, we did A, B, and now we're going to add a part C to this. Okay. What is the height of this tower? What is the height of this tower? Not the length of the tower, the height, right, from the ground up. So I will just do a quick little sketch here. The triangle that we drew earlier had the following, can be summarized as follows, right? We now know that this is 400.76 feet. We know that this is 27 degrees. And like we basically know all sides. This is 184.75. What's that?
Do we already do
B we did yesterday. Yeah. It's right up here. And we know that the bottom here is 325. So if you remember, if you went through my notes, right, the height of a triangle is always measured, right, to the top, and it goes right down to the ground, right? This is the ground here, and it makes a 90. So this is the height of this particular tower. It would be measured from the top right down to the bottom at a 90. That's the height. And there's a little shortcut I gave you for height. Height in this case would be what? You go, it's this side times the angle that is adjacent to that side. So in this case, it would be, we call this C. It'd be C times sine of B in this case, because we call this angle B, and this was side C, right? So the height of this triangle would be 400.76 multiplied by sine of 27. That automatically gives you the height of the triangle. Even if it's an obtuse like this, right, it still applies. It could have gone this way, right? It doesn't matter. You take this side and the sine of this side. And in this case, it ends up being 181.94 feet. That's just an aside there. But I also want to show you something else that's pretty cool. right? Another thing you could do, like if you're coming from this side of the triangle, you could take this side and multiply it by the adjacent angle coming from this side. So 184 times sine of 100 would give you the same height. So you can come from this side of the triangle or from this side, it doesn't matter, it works the same. Or we call this b here, right? B times sine of c. We call this c here above in that original. H is going to be 184.75 times sine of 100. And you get 181.94 feet as well. So you're coming from this side, just do this side times sine of that, or you can come from this side and just go this side times sine of the angle adjacent to it. And it goes back to, remember when we split the triangle, like I gave you one of these, we split it and we found this side, so we chose to work with this. You can also find this side and then split the triangle this way and solve for the height using this side. So both sides work. This is the shortcut, okay? All right, so now we're going to do the AC.